Hello everyone, welcome back to the Microservice Masterclass. In the previous episode, we discussed distributed transactions. We understand what happens when one business operation spans between multiple microservices and their database. For example, order service creates an order, inventory service reserves the product, payment service process the payment. If all three operations succeed, there is no problem. But what happens when the order is created, inventory is reserved, and then payment is filled? The first two service has already committed their database transaction. We cannot use a normal database rollback because every service owns a separate database. This is where the Saga patterns help us. In this video, we will understand what the Saga pattern is, why microservices need it, how local transaction from form a saga, how local transaction form a saga choreography, event-based communication, successful and failed transaction flow, compensating transactions, benefits, limitation, and appropriate use cases. So let's begin. A saga is a sequence of local transactions that together complete one distributed business operation. Let's understand that statement using our order example. Placing an order is one business operation, but technically it contains multiple transactions. Order service creates the order, inventory service reserves the stock, payment service processes the payment, order service confirms the order. Every step is handled by different services, and every service commits its changes to its own database. The Saga pattern does not create one large database transaction across all services. Instead, it coordinates multiple independent local transactions. If every step succeeds, the complete business operation succeeds. If one step fails, the Saga executes compensating action to reverse the effect of previously completed steps. Why do microservices need Saga? In a monolithic application, order, inventory, and payment tables may exist in the same database. We can update them inside one AC transaction. If fail, if payment fails, the database can roll back the order and inventory changes. But in microservice, order service owns the order database, inventory service owns the inventory database, payment service owns the payment database. A local database transaction cannot control all three databases. If we could use two-phase commit, but as we discussed in the previous episode, it can create long-running blocking operation, coordinator dependency, reduced availability, tight coupling between services. Saga provides a more suitable alternative for many microservice workflow. It allows every service to remain independent while maintaining business consistency through the local transaction events and compensating actions. What is local transaction inside a Saga? Look at the successful flow at the top of the diagram. Every service performs a local transaction. Every service performs a local transaction. The order service creates an order, commits it to the order database. It does not keep the database transaction open while waiting for inventory and payment services. After committing the order, it publishes an event. The inventory service receives that event, reserve the stock, and commit the changes to its own database. Then it publishes another event. The payment service receives the inventory event, receives process the payment and commit its own transaction. Notice something important. There is no single transaction covering every service. Each service is responsible only for updating its own database and publishing the result of the update. This combination of local transaction and an event moves the saga forward. In production, database update and event publication should be handled reliably, usually through the patterns such as transactional outbox, which we discussed earlier. Successful order inventory payment flow. Now let's follow the complete successful so, now let's follow the complete successful saga flow in the diagram. Step 1 creates an order. The customer Step 1 create the order. The customer places an order. The order service creates it with an initial status such as pending. After committing its local transaction, it publishes order created. This Step 2 is reserve the inventory. The inventory service listens to the order created event. It checks whether the products are available. If stock is available, it reserves the product and publishes. Step 3 process the payment. The payment service listen for inventory reserve. It changes the customer. If payment succeed, it publishes payment completed. Step 4 confirm the order. The order service listen to the payment completed. It changes the order status from pending to confirmed. The complete saga is now successful. Each service each service knew only which events should consume and which events should publish. No central component controlled the complete workflow. This style of saga is called Saga Choreography. Saga Choreography, the word choreography comes from the dance. In the in a coordinated dance, every participant know when to perform its step by observing that observing what happened before it. There may be no central person issuing every instruction. Saga choreography works similarly. Every service reacts to events produced by other service. The flow looks like order created, inventory reserved, payment completed, order confirmed. The order service does not directly tell every service what to do. The order service does not directly tell every service what to do. It announces that an order has been created. The inventory service react to that event. Payment service then react to the inventory event. This creates the decentralized workflow. Every service remains responsible for its business logic and data. Business logic and data. Events are foundation of the saga. Events are the foundation of saga choreography. An event represents something that has already happened, like order created, inventory reserved, something like that. These events are usually delivered through a message broker such as Kafka or RabbitMQ. Every event should contain enough information. Every event should contain enough information for the next service to process its responsibility. It should also contain important identifiers such as event ID, saga ID, order ID, event type, timestamp, and correlation ID. The saga ID or correlation ID helps us to connect all the events belonging to the same business transaction. Consumers should also be added idempotent because the same event may be delivered more than once. For example, receiving inventory reserved twice must not charge the customer twice. Now let's look at the failure flow in the middle of the diagram. The order service creates the order successfully, inventory service resolves the stock successfully, but the payment service cannot process the payment. Perhaps the card was declined, payment gateway was unavailable, the customer had insufficient fund, the payment service publishes payment failed. At this point, the order and inventory transactions are already committed. The order and inventory transaction already committed. We cannot perform a normal database rollback across two services. Instead, we start a compensation flow. Like step 1 is the release inventory. The inventory service listens to the payment field. It performs a new local transaction to the release the reserved stock. It may publish inventory release, cancel the order. The, the second step is cancel the order. The order service receives the failure and inventory release event. It changes the order status to cancelled. Now the system has reached a consistent business state. Payment was not collected, inventory is available again, the order is cancelled. This is how Saga recovers from the partial failure. Compensating transaction is a new business operation that resolves the effect of an earlier committed operation. For example, order created to order create order to cancel order, reserve inventory to release inventory, charge payment to refund payment. Noting something important, the compensation is not the same as database rollback. A database rollback removes the changes that has not yet been committed. A compensating transaction operates on changes that were already committed. It creates another valid business record that receives their effect. For example, if a payment has already been captured, we do not delete it. From database. We create a refund transaction. Similarly, if an order has already been created, we do not simply remove its history. We change its status to cancelled. The preserve audit history. This preserves the audit history, accurately represents what happened. Benefits of the Saga Choreography. Saga Choreography offers several benefits. First one is the loose coupling, service communication using the event rather than direct workflow command. No central coordinator. This is no signal. There is no signal. There is no single orchestration service controlling every step. Independent services. Every service on its own data and business logic. Scalability. Event consumer can be scaled independently according to their workload. And better availability. Services do not need to hold distributed logs while waiting for the other service. Natural fit for event driven system. If the system is already uses the message broker, choreography can integrate naturally with the existing architecture. But it has some limitations as well. Saga Choreography, like difficult workflow visibility. The complete business flow is distributed across several services. Complete business flow is distributed across several services. Looking at one service may not reveal what happens next. Complex debugging. To understand one failed service, we may need to trace event across multiple services. Cyclic event dependency. Poorly designed service may keep reacting to one another's event and create confusing event chaining. Difficult changes. Adding a new step may require modification to the multiple producer and consumer. Eventual consistency. The system may temporarily show intermediate and stale state. Failure handling. We must carefully handle duplicate events. missing events, retry, timeout, and out of order delivery. Therefore, strong observability is essential. Log, metrics, traces, saga ID, and event timeline. So, should help us to understand the complete journey. When should we use the choreography? Saga Saga choreography work best when the workflow contains a small number of services. Okay, workflow contains the small number of services. The sequence is straightforward. Event relationships are easy to understand. Services already communicate through events. Temporary eventual consistency is acceptable. Teams won't lose coupling without a central coordinator, but with the workflow contains many additional steps, complex compensation rules, or long running operations, choreography may become difficult to understand. In those cases, saga orchestrations in those cases the saga orchestrations may be better options. Conclusion. Let's quickly recap the complete diagram. A saga converts one distributed business transaction into a sequence of local transactions. Each service commits its own database change and publishes an event. In Saga choreography, there is no central coordinator. The order created event trigger inventory reservation. The inventory reserve event trigger payment processing, and payment complete confirms the order. If payment fails, a new business operations release the inventory and cancel the order. These are called compensating transaction. Choreography is decentralized, scalable, and loosely coupled. But as the workflow grows, debugging, event tracking, and understanding the complete flow become more difficult. That brings us to next question. What if one central component could explicitly control the saga and decide which steps should execute next? That is exactly what we will understand in episode number 16, part 2, saga orchestration. If you found this video useful, please like the video, subscribe to my channel, and share it with anyone learning microservices and system design. Thank you for watching. I'll see you in the next part of our microservice masterclass.